Hello students, welcome all. Welcome to Cryptography and Network Security class. In another class, today we'll discuss about message authentication. So we have already completed fundamental of cryptography, asymmetric, symmetric cryptography, and different examples such as DES, AES, these algorithms, RSA, Robin crypto system. We have covered all these things. And today we'll discuss about the message authentication. This is me, Asis, and this semester I will take care of your cryptography and network security courses. I'll be there for your doubts and all. So, dear students, in today's class, we'll discuss about message integrity, message authentication, criteria for cryptographic hash functions, distinguish between MDC and MAC address, and discuss some common MACs. So this particular topic is all about how to check the integrity of a message. Suppose you send a message to your friend and your friend received the message and you just deny that you do not send that particular message. So message integrity is such a thing who actually dignify the originality of the message and justify the sender that the sender must have sent the message. That is message integrity. It protects the originality of the message. Message authentication means the message must be in original state and the message must be uh, owned by the person who created and sent by the person who sent it. Nobody can deny that I can't do this with this message. So, moving to the next part of this message integrity, we can define the message integrity as a document, electronic document, or a fingerprint pair. Okay. Now, question arises that how to check this message integrity in digital world. The message comes with a message digest. Message is the document, then message digest is a document. So both can justify the integrity of the message. The second point, what it is written, to preserve the integrity of a message, the message is passed through an algorithm. The message is passed through an algorithm, that is hash algorithm. The function creates a compressed image of the message that can be used like a fingerprint. We actually give a justification towards the integrity retained for the message what we have sent. Clear? Next, this is the diagrammatical representation of the definition what we have studied in last slide. We have a message, we have a document. That document pass through the hash function and it will create a message digest, which is the fingerprint of that message that can be checked to check the integrity of the message. Then Message authentication. As I said, a message digest must guarantee the integrity of the message, and it also guaranteed that the message has not been changed, and it also justify that the sender of the message is not, it cannot able to deny that the message can't be sent by that message. If so, then we can't justify someone else has sent some abusive message to our number in our phone, and we can't justify that that person is sending such and such message. So it is disrespect and disobey to the law. That's why message integrity digest is required to justify the message integrity. However, the message digest not authenticate the sender of the message. For that, non-repudiation is there, but non-repudiation can be achieved through the CIA confidentiality, integrity, and availability triangle. Okay, then if something modified in the message, so modification detection code will be there that can prove, that can prove the integrity of the message, and that can prove the authenticity of the message also, that it can prove that message has not been changed. If message has changed, then we have some policy or we have some code to detect it, like this. This figure represents the modification detection code. Like Alice is there who has the message. Alice just hashed it and make MDC and send it through secure channel. Bob has MDC. Bob has received the same MDC from Alice, and now Bob also has that message, and Bob has hashed it and created the MDC. And if the both MDC is same, then Bob will accept the message, else it just reject the message. How cleverly it checked the message has been transferred to the Bob in an insecure channel, and already it created MDC and checked it. Next is message authentication code, MAC. To ensure the integrity of the message and data origin authentication, that Alice is the originator of the message, not somebody else. We need to change a modification code. We need to change a modification detection code to a message authentication code. So we need a change to MDC to MAC. Okay. Now, what is the difference between MDC and MAC? In inclusions or in today's topic, I have clearly mentioned that MDC and a MAC is that the MAC include a secret between Alice and Bob. For example, a secret key that Eve does not possess. So in this message authentication code, two people, those who are in secure channel, they must have some secret key who can justify the message and who can justify that the message is authenticated through a code, and MDC is just to check the message integrity. If we say There are many cryptographic algorithms there like DES, AES. If we talk about the symmetric key encryption, there are DES, AES. If we go for asymmetric crypto system, there are RSA, Robin crypto system, Algamal crypto system. So is does the all crypto system algorithm are not that much sufficient to check the message integrity? The question should be arise. Okay, and the answer is they are only cryptographic algorithm. They only encrypt the data, encrypt the message into a ciphertext so that message can be protected. They can convert the plain text into a ciphertext so that message can be protected. Okay, but this message integrity is we are checking that particular message or the particular data is original or not. The message originally, the way the message is, it is the same the way receiver received it. It is there or not. It can be checked. Moving to the next, we have a picture over there. How message authentication code work? If we see here, we have the sender Alice and the Alice has the message M. The M has with a key and create a MAC, message authentication code. Okay, now this message and this MAC, including both, it passed through a insecure channel, reach to the Bob, message and MAC. So M plus MAC. So this message again with a key going through a hash and got a MAC like this. Then this MAC and this MAC. This MAC, if both the MAC are same, then it will be accepted, else it will be rejected. Okay, so the way MAC work, message authentication code work. Here the legend shows M stands for message, MAC message authentication code, and K a shared secret key. This is a shared secret key. Like in previous slide, we have seen that a secret key between Alice and Bob. So the third person cannot be able to access this particular message. How clever, how beautiful, designed. Okay, next we move to cryptographic hash functions. Cryptographic hash functions satisfy three criteria. First one is pre-image resistance, second is second pre-image resistance, and third one is collision resistance. This is very interesting and very important concept, the cryptographic hash function, because we have already discussed message authentication code, message modification code to check the message integrity, message digest. Now this cryptographic hash function, the pre-image resistance, second pre-image resistance, and collision resistance, these three, they are creating or they are used for different prospect. or you can say that a hash function, when a message convert with a hash function, that create a secured message digest that cannot be reversed back. I will tell you one example. Okay, just 1 minute. I will tell you one example. Yeah, when the message is sent by a sender and at the receiver end, when the message has been checked for the integrity, when the message is checked for the integrity, they generally use a cryptographic algorithm to check. Yes, but this cryptographic hash function that can be used to check the message with a message digest. Okay, so the pre-image resistance is a particular type of checking that create a message digest type of thing and that resist the attack by which the message can be saved. Okay, now just think that there are 7 layers in a network, and in that network, on which layer we are doing all these things. Okay, there are transport layer, there are network layer, and in this two layer we are defining so much protocols that protocols secure the transportation process and communication channel by which we can able to find out the different different protection for the message. Okay, likewise the pre-image resistance is that a cryptographic hash function must be pre-image resistance. Okay, so it must be extremely difficult for third person to find any message m dash, that is the message digest, such as that message cannot be able to find by the third person. For example, a message is there, it is going through hash function and the equation has been derived y equal to hm. Let's say it is a message is there after hash, this is y equal to hm. Okay, now given this y, any m dash, that would be y equal to hm dash. So when attack is been done, y find out So if the hash function is not pre-image resistance, a third person can intercept the message HM and create a message M dash. So the third person can send M dash to any sender and pretending that it is M. So this is pre-image attack. Okay. Then second pre-image is sender hash the message and create an HM, then send that message and HM to the receiver, and that message and HM must be same match to um, same as the receiver's message and HM dash. If both can be same, then the third one collision can be created. That is the collision attack. Find M and M dash such that M not equal to M dash but HM equal to H of M dash. If this condition occur, just a minute, if H of M equal to H of M dash, then this condition is called as collision. Okay, so this is all about the message authentication and it's fundamental. If you have any doubts, do reach out to me. Okay.